Hello everyone, welcome to Code with Femi. This is the final episode of this Solid Principles series. We're going to be looking at Dependency Inversion Principle. We've actually looked at all the necessary the key most of the principles. We've looked at S, which is single responsibility principle, O for open closed principle, L for Liskov substitution principle. We checked interface segregation principle, and now we're finally on D, which is the final one of the solid principles. And in there, the actual principle states that high-level modules should not import anything from low-level modules. Both should depend on abstractions, like interfaces. You can see that. And B, abstractions should not depend on details. Details, which is your contract, your concrete classes, should be the one depending on abstraction. And the reason why we implement it this way is because there are cases where you want to be able to make some changes to your concrete implementation. And I'll give you a scenario. Let's say, for instance, you have an app that sends SMS to people, but for some reason the service provider you are using is actually giving a lot of problems. Maybe they're having too much downtime and you want to switch to another service provider. This is where dependency inversion can actually save you a lot of time, because you don't really need to worry about like changing the concrete class and fixing it to now work with the new service provider. You don't have to do that. All you need to do is to just switch it to another new provider. So let's actually start. Let's say that you have your first class. I don't want to use any service provider here, so that it won't be as if I'm making them feel bad. I'm just gonna say a service provider. Okay, sorry, provider. Sorry, let's switch to my screen so you can see what I'm doing. Let's just start all over again. So just create a new one, which is we create a new so this is actually the service provider we're using to send SMS. The first one is a service provider. Okay, so we have a service provider, right? And service provider actually has public, let's say it has some private fields here, like private or public. Let's make this public string and say your cell phone number. Okay, let's say we have something like the cell phone number, and then we say public dot void dot send SMS. Yeah, and then we just send SMS. Like let's just console log this, right? Let's say sending SMS to the cell phone number that we just got now. To cell phone number, cell phone. So this is actually it. We actually sending, let's say we're sending SMS through the cell phone number, right? And now the actual thing is, we have, let's now say we have another class. Let's call this let's call this a person class, right? So the person is actually the one using the service to to send the SMS. So let's say this is the person, and then in here, this is what we're actually using to send the SMS. To say, let's say we have a method here which says public void, and then let's say deliver message. Okay, deliver message, and then we have the actual let's say we have the actual cell phone coming in here. You say cell phone, terminating it there, sorry, remove the so, and then we're trying to deliver a message here, but now this is what is actually going to go against this principle we've just stated, which is me now saying this, doing a service goes to a service provider is equals to new service provider, right? And then we're now saying a service provider dot cell phone is equals to cell phone, right? And then we say a service dot send SMS, right? That's what we're doing now. But basically what we've now done is this: we've actually like made this tightly coupled to this actual this actual method, this actual class, which makes it tightly coupled, like it goes against this rule. Because remember, we say that high level modules should not import anything from low level modules. Both should depend on abstraction, because what we've now done is in our code we've gone against that rule. And also it says abstraction should not depend on details, but details should actually depend on abstraction. So we just have to make sure that we bear this in mind whenever you do something like this, where you are instantiating a class within another class. What you're doing is this actually tightly couples this class to this class, which means that you can also see even the actual phone now is being set in here, which is quite not great, right? And I'll tell you why this is not great. So let's say, for instance, I have this person, right? I'm just gonna call this person from now. I'll call this person from here to say var person equals to new person, right? Say person dot deliver message, and then I'll just give it my number, whatever number is that. But now what we have here is fine. When we run this app, it's gonna deliver the it's gonna deliver the message, it's gonna send the message. But I'm also gonna show you now what's gonna happen in a situation whereby for some reason the actual service provider, so you see now it's actually sending message, right? You're happy, yeah? Good. So now let me now go back to service provider, and then in here, after logging this, I'm gonna throw new exception. So just for me to explain what I mean there. So what I'm trying to say now is, let's say for instance this service now is actually having problems. There's a lot of problems happening with them. Now you're running your app, and for some reason it's breaking within this service. Like it's breaking. You can see there's an exception. Oh no, like it's always happening where or it can even happen before it's sending out. You can see another exception, but it can even happen where before it's even sending the message. Let's say that it's even happened before, you have a lot of logic. Let's say you have a lot of logic in here, and then at some point there, before it sends this, it's breaking. It's actually breaking. It's not even like getting to a point where it's even sending any message to any any recipient. The next thing you want to think about is an alternative, right? Like you want to think about how am I going to like come up with an alternative to switch this thing out, because now you want to now use another service. You want to use, like, let's say you want to use another entire service. You want to use B service provider. Now the problem we have currently now is because this actual A service is tightly coupled to to the actual person class. This actual class is tightly coupled to that class, and that makes it a lot more difficult, because now you can change things in here to fix this class to work as B service provider. But guess what? You're bringing even much more problem into your software, which you shouldn't actually really do. So this is where you think about dependency inversion, where you can invert your dependencies, because this is actually a dependency. What do I mean by that is person actually depends on this actual class, this actual provider. But now we want to find a way of inverting it in a situation where we want to like use another provider. So now this is how we're going to solve the problem. Let's create a new class and call this class B service provider. Okay, we'll call this B service provider. This B service provider public would actually now be a it's also gonna do the same thing. It's just that the actual implementation will now be a little bit different. Now also remember that we can actually also just pass in our cell phone here, so we don't really need to use this. We can actually just pass in the cell phone directly into this method, and then we can have something happy here. So with that, another thing we can also do is that because with this now, to solve the problem we need an interface. So I'll call this iService provider. So with iService provider, it seems we do have, okay, let's call it something. Let's just say ISMS. Let's say ISMS service provider. That's the one we're gonna use. And then let's just create the interface in here. So with that, we just create the interface in here, ISMS service provider, and then what we want to do is we just want to expose that actual contract in here. Say you can actually call this now, make it this public, so which means that now we have a service, an interface for iService provider that has been exposed now. So what this actually helps with now is that we don't really need to use in the person's class, we don't need to instantiate this anymore like this. What we can now do is we can have something like this: private read only. And what read only really means is that you only just want to set it in you can only set it in the constructor, but you can read it anywhere else. So this is the only place you can actually set it. If you try to set it anywhere else, it's not going to allow you to do that. But now you're passing in the actual interface now into this class to be used. So this makes your class like loosely coupled from this concrete class that we had initially, which is this guy. So IA service provider now can actually be gone. You don't even need it. You can take that out, and then you can now use this, and then you can just pass in your cell phone in there. And if you check your A service provider, we just have to make sure that we remove that as well, because the reason why it's complaining is because the signature here doesn't match what you're exposing there. So you just have to resolve it by making sure that they have the same signature, and everything will be fine. So for instance, if I have this now, I'm just gonna still keep this exception that I'm throwing here, just for you to just understand what I mean. So let's just say this thing is still throwing, it's still causing problem. A service provider is still a big problem for us, but B service provider is actually like fine, but now we want to use it, want to switch to it, because this other guy is just giving problem. This guy is giving, but now guess what? This person doesn't care. He doesn't really worry about any concrete class. He's not, he's not aware of any, implementation. All he cares about is the interface, and with that interface, it will just, call the actual method. So as far as person is concerned, he doesn't even know if you're calling B or A service provider. So And at the top level, this is where you can invert it to say that since since I'm having problems with 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 a service provider, I can actually just pass in B service provider in here, and that will solve the problem. Because now if I run this, you would see now that I can still deliver my message without any problem. Like you can see the SMS is back, we're running now, we're fine again. But if I say okay fine, let's switch back to A, you will see there that it's actually going to tell me no, A is not still good. You can see it's still telling me A is not still good. And this is how you can actually invert, you can do your inversion of your dependency. And also that also leads me to something we call dependency injection, because right here also this place as well is also tightly coupled to programming. If you think about it, this actual person, it's actually tightly coupled to program, and we don't really also want this scenario to happen. So in my future videos, I'm gonna show you guys how we can use dependency injection, because we do have like inbuilt in .NET Core. Now we have inbuilt dependency injection that can help you resolve your dependencies at runtime. You just have to register it, the startup class, and then it would actually, you can easily use it. So you won't have to always rely on actually like your concrete classes. You can actually just depend on your interfaces to actually do the necessary things that you need to do in your code. Because you can see here now, like person is just happy, all he knows is just service provider, but this thing can change from service A to service B. And if you want me to prove that to you, I can put a breakpoint here and you will see what I mean. So yeah, I'm using service A, and if I run this actually, I will see now when we go on to, you can see we're calling person. Inside of the person, you can over on here, and there you can see it says the solid app A service provider, right? Let's stop this. Now let's go back to the program class and change that to B, and then we'll run this, and you will see that the same thing also happens, which is, to me, I feel like that is amazing. Like you can switch at any time, that and I've seen in cases even where people are like they were previously using a certain DB technology, and they decide to switch to say no, we don't want to use this DB technology anymore, we want to use another one. This is where dependency inversion actually helps easily, because now you can swap it out without having to worry about breaking anything. You can thoroughly test that new feature you're bringing in, and actually like just put it in, and just plug and play, and then you're good to go. I hope I was able to give you guys like information as to how to write quality code, because it is very important, it's very crucial, and especially if you're going to be working with other developers, it's actually very good to follow certain patterns, to actually agree and say these are the principles we're going to follow and stick to it. It's all about discipline, making sure that you disciplined enough, you act as a professional, and also think about the next guy, set the next guy for success. Don't write smelly code, don't just write code because you want to write it, but make sure that you write it following the agreed pattern, the agreed standards. And I hope you guys get grow in your space and become excellent. And I will see you in my next video. You must keep well. Cheers.